Hello, this is Mr. Stansbury. I'm going to take you through the 10I notes on using the sine and cosine rules. At the end of this, you should be able to say, I can use sine and cosine rules to solve real-world type problems. Okay, so let's kind of take a quick overview of sine and cosine rules. So cosine rule we use when we're given three sides or two sides in the included angle, and then we use the law of sines when we're given one side and two angles, or two sides and the non-included angle. All right, so let's take a look at an example. So this is similar to example 23 from page 344. The angles of elevation to the top of I should have built my house somewhere else castle are measured from 2 points A and B. How tall is the castle from the water to its highest point? So what I'm thinking is if we can figure out what this side is, then we can use the our trig ratios. You can use sine to figure out the opposite side over the hypotenuse from that angle. So if we can figure out this side, we're in business. So we have this side here is the only length that we know. So if we want to use law of sines, we got to figure out what this angle is here. So we can do that by first figuring out what this angle is, and then we can figure out what that is. So to figure out this angle here, let's just do 180 minus 41.2 degrees. So 180 minus 41.2 gives us 138.8 degrees. Okay, so now to figure out this angle here, we are just going to do 180 subtract these two angles, right? Minus 29.7 and also subtract 138.8. So because the three angles of a triangle always add up to 180, right? So 180 minus 29.7 and minus 138.8 give us that this angle up here is 11.5. So this angle here, 11.5 degrees. So now we have an angle and the side across from it, so then we can use the other angle and the side across from that to figure out what this is here. So let's do this. Sine of 11.5 is to 1473 as sine of 29.7 is to this side here, let's call it x. So we just do cross products, right? This times this equals this times this. So x sine of 11.5 equals 1473 sine of 29.7. So if we divide both sides by sine of 11.5, then we're in business. So here's our sine of 11.5, divide that both sides. So we'll just get x equals this business here. So let's figure that out here. We've got 1473 times sine of 29.7. That gives us 729.8. Now we want to divide that by the sine of 11.5, and that gives us 3661, we'll call it. Okay, so this is 3661. Okay, so now that we know that, again, we can now figure out what this height is here by just doing a simple law of, but just the sine ratio. So we can do sine of 41.2 equals the opposite side, which is what we're looking for. Let's call that the height, divided by the hypotenuse, which is 3661. 3661. Multiply both sides by 3661. And we get that the height of this building here is 3661 sine of 41.2, and we get 2,411 feet about. Or sorry, 2,411 inches if I stick to our inches that we had here. Okay, so that's the height of that castle. So that's one way to go through and figure that out. All right, let's take a look at another concept that we covered earlier in this class, and that is bearing. Okay, so true bearing is the angle measured from true north, and this is kind of a tricky concept. A lot of people have a hard time with this, so let's see what we can do to get this figured out. So for the diagram given, find the bearing of B from A, and then of the angle of bearing to C from B, and then to A from C. So first thing we're looking for, here's true north. We want to figure out what this angle here is, and guess what? It gives it to us. This is 38 degrees. All right, just true north to whatever the angle is that you're heading to get to B. Okay, so let's do, now we got to do C from B. So here is true north for B, so we got to figure out what this angle here is. Okay, I think probably the easiest way to figure this out is, since these lines here are parallel, these are let's see, co-interior angles? Yeah, co-interior angles here. So these two have to add up to 180 degrees. So let's do 180, but we've already used 38 of those on that, and that gives us 142 degrees for this here. So then we know that this whole thing makes 360. So to figure out what this bearing angle here is, we'll do 360 minus 94 and minus the 142. Okay, so let's try that out. So let's start with 360 minus 94 minus 142, and that gives us 124 degrees for right here. Okay, so we've got the first two. Let's see if we can figure out the last one, and then away we go. So now we want to figure out the bearing of A from C, right? So we want to figure out what this angle here is. Now the good news is we already have this piece here. If we can figure out what this piece is here, then we can just subtract it again from 360 like we just did to figure out what this angle is left. And the good news is, again, these are going to be supplementary angles right here. So we're going to take 180 degrees and minus this angle here, which we just figured out is 124. That's a 0. Close enough. And then let's see, we get that this is 156. No, not 156, but just 56. Okay, so this here is 56 degrees. So then to figure out what this is, this bearing angle here is, we're just going to do 360 minus the 45 and minus the 56. All right, so if we do that, 360 minus 45 minus 56, and we get 259 degrees. So then that's our bearing angle. All right.